India's lunar mission was called Chandrayaan 2. It was launched on July 22, 2019 by the Indian Space Research Organization, ISRO. Chandrayaan 2 was an unmanned mission with the goal of exploring the lunar surface, studying its geology, and searching for water ice. The mission included an orbiter, a lander called Vikram, and a rover called Pragyan. Chandrayaan 3. It is the third lunar exploration mission by the Indian Space Research Organization, ISRO. The Chandrayaan 3 mission is aimed at furthering India's exploration of the Moon's surface. Chandrayaan 3 is a follow-up mission to Chandrayaan 2, which launched in July 2019. Chandrayaan 2 consisted of an orbiter, a lander named Vikram, and a rover named Pragyan. However, the lander, Vikram, encountered difficulties during the descent phase and landed on the lunar surface, preventing a rover from being deployed. In response to the partial success of Chandrayaan 2, ISRO decided to undertake the Chandrayaan 3 mission with the goal of achieving a soft landing on the moon's surface and deploying a rover. The United States has had several moon missions throughout its history. The most well-known and significant moon missions by the United States are the Apollo program missions. Here are the key Apollo missions related to the moon. Apollo 11. This mission, launched on July 16, 1969, was the first crewed mission to land humans on the moon. Astronauts Neil Armstrong and Buzz Aldrin became the first and second humans to walk on the lunar surface on July 20, 1969. Apollo 12. Launched on November 14, 1969, Apollo 12 was the second mission to land humans on the moon. The crew, consisting of astronauts Charles P. Conrad and Alan Bean, performed scientific experiments and explored the moon's surface. Apollo 14. Launched on January 31, 1971, Apollo 14 was the third mission to successfully land on the moon. Astronauts Alan Shepard and Edgar conducted scientific experiments, collected samples, and explored the Fra Mauro formation. Apollo 15. Launched on July 26, 1971, Apollo 15 was the first of the J missions, which featured longer stays on the moon and the use of the Lunar Roving Vehicle. LRV astronauts David Scott and James Irwin explored the Hadley, Apennine region and conducted extensive scientific research. Apollo 16. Launched on April 16, 1972, Apollo 16 was the second mission of the J missions. Astronauts John Young and Charles Duke explored the Descartes Highlands and deployed scientific instruments. Apollo 17. Launched on December 7, 1972, Apollo 17 was the final mission of the Apollo program and the last crewed mission to the moon to date. Astronauts Eugene Cernan and Harrison Schmitt explored the Taurus, Littoral region and conducted geological studies. These Apollo missions played a crucial role in advancing our understanding of the moon's geology, conducting scientific experiments, and collecting valuable samples. They represented remarkable achievements in human space exploration and remain historic milestones in space exploration history. Why moon mission is so important for space program. The moon has been a target for human exploration for several reasons. Scientific exploration. The moon provides a unique opportunity for scientific exploration and research. By studying the moon's geology, composition, and history, scientists can gain insights into the formation of the solar system and the early Earth. Moon missions have helped us understand the moon's geological processes, impact cratering, and the potential for resources, such as water ice. Human spaceflight experience. The moon serves as a valuable platform for human spaceflight experience and technology development. Sending humans to the moon allows us to test and refine technologies, systems, and procedures necessary for longer duration space missions, such as those to Mars or beyond. Potential for future exploration. Establishing a sustained human presence on the moon can serve as a stepping stone for future exploration of other celestial bodies, such as Mars and asteroids. The moon's proximity to Earth makes it an accessible target for developing and testing technologies needed for more distant space missions. Resource utilization. The moon may hold valuable resources such as water ice in permanently shadowed regions near the poles. Water can be used for life support, fuel production, and as a valuable resource for future space missions. Understanding and accessing these resources could enhance the sustainability of future human space exploration. International collaboration. Exploring the moon has the potential to foster international collaboration in space exploration. Projects like the International Space Station, ISS, have demonstrated the benefits of international partnerships, and the moon offers another opportunity for countries to work together on shared goals and scientific advancements. Inspiring future generations. Human exploration of the moon captures the imagination and inspires people around the world, particularly young students, to pursue careers in science, technology, engineering, and mathematics, STEM, fields. Moon missions have historically been seen as symbols of human achievement and have the potential to drive scientific and technological advancements. Overall, the moon serves as a natural satellite that offers scientific, technological, and strategic advantages for human exploration. By returning to the moon and expanding our knowledge of it, we can pave the way for further space exploration and potentially lay the groundwork for future
human settlements beyond Earth.